Welcome to our webinar. My name is Victoria and I am your host for today. Before we start with our presentation, I will give you a few remarks for your information. Please feel free to type in any questions that come up during the webinar in our question box. You should see it at the top or right side of your Microsoft Teams window. It is called Q&A and the icon looks like a speech bubble with a question mark. We will answer as many questions as possible at the end of the webinar, and if there are too many, don't worry, we will answer everything via email within the next days. This webinar today is being recorded for you, so you will automatically receive the video within the next days by email. And one last piece of information, this webinar will take place again today at 5 p.m. German time with the same content, which is 12 p.m. Eastern USA time. So if you have colleagues for whom this time is more suitable, please forward the registration link, which I will post to you as a message in a moment. Now, I would like to introduce you to our today's speaker, Dr. Mohamed Bousbib. Mohamed holds a PhD in chemistry from Edward Loránd University in Budapest. He is a member of the NETZSCH Analyzing and Testing family, contributing to the development and support of the software Neo team. Throughout his career, Mohamed has published numerous articles in prestigious peer-reviewed journals. Welcome, Mohamed. We are happy to have you here today, talking about unlocking efficiency, optimizing polymer binder burnout process with Kinetics Neo Software. I will now hand over to you to get started. I will be back for our Q&A session at the end, so enjoy our webinar and have fun.
Thank you very much, Victoria, for your kind introduction. And a warm welcome from my side to everyone joining our webinar today. In today's webinar, I will show you how we can do the optimization of the polymer binder burnout process as a critical step in materials manufacturing. I'm confident today that after today you will learn more about kinetics in solids and how Kinetics Neo Software can help you in order to optimize polymer binder burnout process in powder metallurgy and ceramics processing, and also other industries. So before moving to the technical part of the talk, I will give you a short introduction to the NETZSCH group, and maybe this is the first NETZSCH webinar that you have been to. So the NETZSCH group is a family-owned company established in the early 1870s in Zerb, in the north of Bavaria region in Germany. So right now it's more than 150 years. We have 3 different business units. We came from the analyzing testing business units, which specialize in the design and manufacture of instruments for thermal analysis, rheology, and fire testing. And we have also the other 2 business units, grinding and dispersing. These business units specialize in the design and manufacture of equipment for wet and dry grinding, mixing, dispersing, and other related applications. And finally, the pumps and the systems units, which specialize in the design and manufacture of the right positive displacement pumps for your application. So within the business units analyzing and testing, we have a wide range of products and services covering a wide temperature range from -260 up to 2800 degrees C. So we manufacture instruments for thermal analysis, as I mentioned, thermal physical properties testing, for example, determination of thermal conductivity, and instruments like acceleration rate calorimetry for looking into adiabatic situation, or what might happen, for example, for an energetic material or a chemical, and for example, how much heat will be generated. And we have also equipment for determining the reaction to fire material in line with the international standards. And finally, we have rheological testing methods to measure the Newtonian liquids and soft solids. So within the NETZSCH group, we have more than 4,700 employees and more than 700 employees within our unit. And we turn over than 150 million euro per year. In NETZSCH, analyzing and testing units, we have laboratories and sales and service location globally, and we have a production sites mainly in Europe, but also in Asia as well. This gives you a picture where we are based, and also we have offices across North America and South America, and finally in Sydney, Australia as well. So kinetics in solid. So what is kinetics? Well, kinetics has basically two main aspects: to better understand the mechanism of a chemical reaction, and to also to describe this experimental data with a mathematical model that fit with the experimental data. And second, it's using this mathematical model to predict the behavior of the material in a time temperature which is not so easy or impossible to access. Well, actually, when we are speaking about kinetics, the first things that comes to our mind, it's the Arrhenius equation, as it's the fundamental in chemical kinetics, because it describes the temperature dependence of reaction rate. But let's start with the general one. So basically, we have the conversion, which giving us an idea about the progress of the reaction. And the first derivative with the time, it's called the conversion rate, which equal the Arrhenius equation multiplied by the reaction model. The reaction model, it can be the first order, second order, n order, or autocatalytic reaction. And the Arrhenius equation, it's equal to A, which is the pre-exponential factor, or also known as the frequency factor, which represent the frequency of collision between reactant molecules. We have also the activation energy, and it's the minimum energy what it needs a reactant A, for example, in order to transform from a reactant A to B as a product. Kinetics Neo Software. Well, today NETZSCH not only produce instruments for thermal analysis, but next to the hardware, NETZSCH has a wide range of softwares which can help to optimize your process, as we will see today, but also to prepare and evaluate your thermal analysis data. So how Kinetics Neo can help you, and what kind of data do we need in order to process, and what is the right approach in order to reach the accurate results. This is what we can see in the next slides. So Kinetics Neo Software is a tool for kinetics analysis and simulation of thermoanalytical data. So basically we have in our approach is 4 stages, we can say. The data type, it can be DSC, TGA, dilatometer, dilatory analysis, arc, rheology, or DMA. And then we are importing the data into the Kinetics Neo software. And then we can do the kinetics analysis based in the model base or the model free. The model base, we can use it for the multi-step model when we have, for example, overlapping step or something, or or more than two single steps. And also we can use the model free for the single step, and also sometimes with some exception with for the multi-step. And after doing the kinetics analysis, we can get the kinetics parameter data, for example, the activation energy, the pre-exponential factor, the reaction model, and the coefficient of determination, which is the R square, which giving us an idea about the goodness of the fit. Then we can go to the third or to the prediction, that we can do the prediction at different temperature condition, isothermal, dynamic, and adiabatic. And then we can also go to the last stage, which is the process optimization. And in this step, we can do the process optimization, so we can reduce the time, and while we can increase the quality of the material, or even we can keep the same quality of the material by reducing the time. So for Kinetics Neo, it supported all types of measurement: rheological measurement, DMA, dynamic mechanical analysis, differential scanning calorimetry, DSC, the thermogravimetric analysis, dielectric analysis, dilatometer, For example, in this case, we have experience with the dilatometer when we have doing the process optimization during the sinterings for ceramics, and also we can use the arc accelerating rate calorimetry. For the Kinetics Neo, that we can use data from non-NETZSCH data, and usually it's ASCII file like a text file or CSV. And here we have a screenshot from the software that is showing us the different part of it. So we have the data import or the source data. Here we have a 4 file, as you can see, which means that we have a different heating rate or for heating rate 1, 2, 5, and 10. Then we can go to the second step, which is the analysis or kinetics analysis, and it's divided in 2 parts, the model free and the model based. And then we have the model design, which can give us the possibility to describe our model by competing consecutive or independent step. Here also we can determine or get all different kinetics parameters. For example, in this case, we have the model base and we have 3 reaction type. And here we have the step B goes to D, and this is the all kinetics parameter of it, the activation energy, the log pre-exponential factor, the reaction order, and the contribution. Also, we have the option of the manual optimization and also the automatic optimization. And we have the statistical comparison that, for example, for professor and in academia, that they prefer to, for example, for the model free that to describe their experimental data by different model, for example, Friedman, Kissinger, Akahira, Sonos, and the others model as well, and then they would like to make a comparison. So here you can click on it and you can show up a table, and based on the ask where which showing the goodness of the fit, you can decide which model is the best in your case. And then the last stage or the last step, it's the simulation. It's divided into part, the prediction and the optimization. As I mentioned that we have also the multi-step model fit in the connection between the steps. So we have the independent. So we will have a mixture of no interacting compound and consecutive when a reaction in the single compound competing, the product depends of the heating rate. And as you can see here that we have a reactant A, and we see that the product is depending on the heating rate. We can see that the percentage of the mass loss is quite different at the end of it. So for the independent, the reaction and the product are not involved in the other steps. The consecutive, the product of one step is a reactant of another step, and the competing involve the same reactant. So this is today I will show you the step-by-step guide how to make the process optimization. But before that, I will give you a short introduction before going deeper. So the optimization of the burnout process of a polymer binder, it's crucial in industries where polymer-based binder are used and later removed through thermal decomposition. So in this case, we can see that the workflow, we have the shaping, the binding, and sinterings. And in today's case, we will focus on the debinding process optimization. So what kind of data we need? So basically, we need at least 3 measurements at different heating rate with the R-square value greater than 0.995. If the value is less than 0.995, in this case, always we are advising the customer to do more heating rate in order to improve the accuracy of the model. And also it's important, it's the reproducibility of the result, which we need to repeat the same measurement under identical condition to ensure that we can get the same result. And by using the thermogravimetric analysis, which give us an idea about the change in the mass of the sample as a function of time. about the conversion, we know all the conversions give us the idea about the progress of the reaction, but how we can calculate the conversion from the TGA data. So basically, we can calculate the conversion by dividing the partial mass loss divided on the total mass loss, and we can get the conversion. And it's usually between 0 and 1 or 0 and 100%. So the first step, or the first that we are doing the measurement by the TGA, so we can see that the composition temperature, we can see here that we have the mass loss versus the temperature curves of the polymer binder for heating rate 5K per minute under nitrogen atmosphere. And in this curve, it can give us an idea about the thermal stability and also the decomposition temperature ranges. So what we can do more than only determine the TGA, the temperature, the thermal stability, and also the decomposition temperature. Now we have Kinetics Neo, which can help us in order to get the kinetics parameters to do the prediction and also the process optimization. So here we made the measurement at different heating rate, basically at 6 heating rate. As you can see, 0, 1, 0, 3, 1, 3, 5, and 10K per minute. And then one of the crucial step is how to determine the number of steps. The easiest way is by visual inspection of the curves, that we can see clearly that we have 2 steps, but in the if the TGA curves show more than one inflection point, looks like an overlapping of 2 or more S-shaped curves, the process is certainly not only single step or just 2 steps. So that's why we need another step, another tool in order to get the confirmation, or to be sure that we have only 2 single steps. So in this case, we use the conversion rate, and it's clearly here you can see that we have 2 peaks which confirm for us the result that we have only 2 steps. Also, we can use the DTG, the derivative thermogravimetric analysis, which represent the rate of weight change with the time, which can give us also an idea how many step reaction we can apply. So after making a different heating rate and determining the number of steps, so now it came to the stage to the kinetics analysis. And as you can see that we describe our experimental data by 2-step reaction, and A goes to B and B goes to C as a consecutive. And in this case, the simulated curves must fit the experimental data. And we can say that the simulation data are in good agreement with experiment, because we have the R-square, or the coefficient of determination, which showing us the goodness of the fits, it's equals 0.999. Also, we can get the different kinetics parameters, the activation energy for each single step, the log of pre-exponential factor, the reaction order, and the contribution. And the contribution here, it's the quantitative contribution of each step to the overall process. And here it's clearly that you can see that the first step it's around 0.77, and the second one it's 0.29, the contribution of each single step. Then we can do the optimization of the profile. So in this case, the optimal temperature profile for the polymer binder, you can see by the mass loss. And for this case, the best material quality at a constant mass loss rate of 1%. Also here, I can show you in the demo live how we can adjust it. You can make it also 0.5, or you can customize as you want. It's up to you. And in this case, we can achieve the optimum temperature profile by controlling the conversion rate. And in this case, we choose the 1% mass loss per minute to obtain the best material quality while reducing the process time. Also, we can Also, as shown here, we can also use the multiple step prediction option in our Kinetics Neo software to provide you with the temperature program at different holding stage or at 5 holding stage as shown in the tunnel kiln example. And here now I will open my software in order to show you how we can do the optimization. So here under the project, we have three main parts. The source data, which is the data preparation, the analysis, which divide in two parts, as I said, the model free and the model based. And also we have the last step, it's the simulation, prediction, and optimization. I will start from the source data. So as you can see that we have a different heating rate, 6 heating rates basically, and we can click on one of them. And you can see that we have the option to prepare our data, for example, by selecting the range. For example, you can select the range and click selected, or you can choose the whole range as well. So this step, we are calling it the preparation of the data. And also we have the option of smoothing. For example, if we click on 6, you can see it's clearly. Also, we have the zoom function. You can see that here the raw data, it's the gray curves, and the green curves, it's the raw smoothed data. So in this case, we will start to decrease the smoothing, and we are seeing how it's going. So in this case, I will choose as a smoothing number 2, and also we can click on reset, and you can see that we back to the first to the initial part. Also, after that, we can come. This part, the smoothing part, is we are using it mostly when we have a bad quality of the signal. So that's why it's really a useful function in this case. So then we have the model. This is our model as I show you in my presentation. And here we have two consecutive steps. You can see that that A goes to B and B goes to C. And here we can go the optimization for each single step. And the second step as well, we can do the optimization. And after that, we can click optimization for the whole model. I mean by the whole model, it's for both steps. And after that, we can use the model summary. For example, for the model summary in order to make a comparison. So in this case, maybe I will make a comparison between a model free and a model base, and I will choose one of them, for example, the flying wall in this case. And we can see the fit, and here we can come to the model summary, and we can click on the R square, and we can see which one is the best. And in this case, it's showing us that the model base with the double step and N order is the best one. We'll back to the model base. I would like to show you the different reaction type what we have in our software, that the first order, the second order, N order, the phase bond, the diffusion, and also other reaction types. So after data preparation and kinetics analysis, we can go to the last stage, which is the optimization of the process. So we can click here on optimization. I will just adjust the heating, and we can click time with the signal. And by this way, we can do the optimization at conversion rate 1%. Also, if you would like, we can do 2%. In this case, we have almost 100 minutes in order to reach 1% of one of the conversion or 100% conversion. If we made conversion rate at 2% per minute, and click calculation, we can see that we reach it in 15 minutes. Also by our software that we can do the prediction at different isothermal. For example, here we have the conversion, and here we can do, for example, between 100 and 500, and for 5 hours, which is 300 minutes, and the temperature step I will do the 50, and we can calculate. And here it's clearly you can see that at different isothermal, when we have the constant temperature as it's shown here, that for example, for the red one, when we have 200, we can see that after 5 hours we can reach 0.56 as a conversion, and for example the 350 we can reach after 5 hours 0.9. So as you can see that by Kinetics Neo Software, just by using at least 3 heating rates and just in few clicks you can optimize your process. And basically here for the conversion we can get also the signal, the conversion, and also the conversion rate. You can see how it's increasing, and we are trying to be constant at 2%. Yes, so back to my presentation. So step-by-step recap. So basically, in order to optimize the process, that we need a polymer binder, then we can do the measurement by TGA, at least 3 measurements at different heating rate. If it's the R square, it's more than 0.995. In this case, it's perfect. Otherwise, we need to do more heating rate in order to increase the accuracy of the model. After that, we are going to do the kinetics analysis. So basically, we are importing the data. We are creating the most suitable model with the different reaction types, can be in order, autocatalysis, first order, second order, and so on. And then we can go to the different output or the results, the kinetics triplet or the different kinetics parameter like contribution or coefficient or determination, the prediction, and also the process optimization. And therefore, industries that we have experience after that, they are going to do the validation of the process. So basically, as a key benefit, we can improve the quality of the product by avoiding the defect like cracking, and also, as you know, that at any internal defect during the debinding stage will get amplified during the sintering. So that's why we are trying to control the conversion rate in this case, and also we reduce the time by optimizing the temperature profile while accelerating the production without losing the product quality. For the energy, we minimize the energy waste by maintaining a constant mass loss, which enhanced effort sustainability, which align with the European regulation. And also, we are trying to avoid the trial and error approach by why speed up the whole process. Yes, kinetics analysis, it's fulfill the ICTAC kinetics recommendation, and ICTAC is an international confederation for thermal analysis and calorimetry. And basically, we have 2 approaches. We are using the model-free analysis and also the multi-step model, or the model fit, in which we are calling it in our software the model base. So how we can get the trial version? So basically, we are advising you to go simply to the kinetics.NETZSCH.com. Then you can click on request trial version. And after a few days, you will receive your software. And then you can go to the learn section. And in the learn section, you have the possibility to explore and to discover our free user guide. And then the software, it's almost for 30 days. And if you find any problem or difficulties, you can reach us on Kinetics kinetics.neo@netsch.com. Thank you for your attention, and for any question, please contact kinetics.neo@netsch.com and webinar_ngb@netsch.com. And with that, I will pass the floor to Victoria.
Yes, thank you so much, Mohammed, for the great presentation. We are now online for a few more minutes to answer your open questions. I'm sorry. So as I already mentioned at the beginning, you are able to ask your questions in our Q&A area. It is an icon that looks like a speech bubble with a question mark. Please feel free to type in any questions you have, and then we will take a look at them. As I said, you will get the recording afterwards via email. Maybe there will be some questions afterwards. Please feel free, as Mohammed already said, to get in touch with our Kinetics Neo email address or our general webinar email address, webinar@netzsch.com. And then, Mohammed, I would say we directly take a look at the first questions. I think we still have some open. I will read the first question right now. What smoothing function or functions do you apply? What is the difference between 2, 3, 4, 5, 6, and so on? Can you help us here?
Yes, it's the degree of smoothing. It's only the degree of smoothing. So just a second, maybe I will take back again the software. Just a moment. So here, for example, if you can see the 6, it will destroy us the experimental data. But for us, we don't need to destroy the experimental data, but we need just to do the smoothing. So that's why we will start to decrease up to 3 or 2. So this is the best smoothing for us. We would like just to remove the noise of the signal. So this is why smoothing is important in this case. That we are using it only when we have a bad quality of the signal. But in this case, our signal was quite perfect. So that's why I made just the smoothing of the degree 2.
Okay, thank you. The next question. Hi, thanks for the informative presentation. Could you explain in detail regarding the multi-step degradation with different temperatures for each zone and its applications? Slide before the 4th live demo.
Sorry, just a second. Slide about this one.
Maybe
I think this is before the live demo.
Yes.
So basically we have, this is the temperature, this is the optimum temperature profile for the polymer burnout. So that's one. But sometimes based on the customer that they have a tunnel kiln, they cannot apply this one. That's why we need to customize this one at different stage. That's why in this case we try to provide him at 5 holding stage, as you can see here. So if the customer has the oven or the tunnel can accept this temperature program, so it's fine. Otherwise, we can also use the multi-step model in order to provide him the temperature program at different holding stage.
Okay, let's see if that helped out. We will wait for 1 more minute. I go on with the next question, Mohammed. How much time do we need to optimize our process if we have Kinetics Neo Software?
Well, actually, to optimize our, if we have the data from the TGA, so it can be just for several minutes or maximum few hours. It depends on the complexity of our data. But if we don't have the TGA data, in this case, we need at least 3 heating rate, and it can be done during the 3 days. So the total process for optimization will be with Kinetics Neo with the TGA data 4 days.
Okay, great. Then the next question. I'm curious about the real optimization. Can you tell us a real optimization story to get a better insight? What percentage did you achieve?
Yes, actually, we have a real story about the optimization of the process was done for ceramics. It's not for polymer for the binding, but it was for the binding and synthetics as well. And we reached up to 50%. And this success story, you can find it in our website. Maybe I can just a second. Okay. It was done by a well-known company. It's named. Just a second. Yes, this is one of our success story, which have done for the binding and ceramic centerings, and we reach up to 50% of our optimization. And it was done by Morgan Advanced Material company. So you can go to our website, kinetics.nethzsch.com application, and you can find it. You can learn more about it, how we did it, but we did it for both sides, for the binding and for centerings as well. Yes, Victoria.
Okay, thank you. Mohammed, I think we got an addition for our previous question about the slide before the live demo.
Yes,
got the information, and doing this type of degradation, is it helpful for doing kinetics? Do you see the question?
Just a second, I got the information. And doing this type of thing, is it helpful for doing kinetics?
There is one more addition. Got the information, and doing this type of degradation, is it helpful for doing kinetics, or does it has application for multi-step degradation? I don't actually know, Mohammed, if we can answer it right now. So as I already said to the attendee who is asking these questions, please feel free always to get in touch via email afterwards. So I think, Mohammed, maybe you show our general email address or your Kinetics email again.
Yes.
And then we can get in touch afterwards to discuss it a little bit further.
Yeah, sure. I will get back to them.
Okay, great. And then I have one more open question for you, Mohammed. Is this process optimization only for the metal powder and ceramic industries, or can we do even more?
No, actually, we can do even more. That we have experience also with the battery industry, biomedical industries, and additive manufacturing.
Okay, that sounds good.
So it's not only for ceramics and metal powders. I chose actually ceramics and metal powders as it's the most for the binding of the polymer, that this is the industry what they are using it the most. So that's why I select them for this webinar. But we have experience also with the battery industries and biomedical and additive manufacturing.
Great, that sounds good. Let's check. So I think, Mohammed, we are through all of our questions for now. I would wrap up the webinar now. As I said, again, please feel free to get in touch afterwards if you have any questions. We will always take care of them. So thank you for your attendance today. Maybe, hopefully, we'll see each other soon in another webinar. Mohammed, thank you so much again for the great presentation.
Thank you so much, Victoria, and thank you for the whole attendees.
Yeah, thank you so much. Bye-bye.